Hello friends, I am Professor Shubham Shedge from Department of Mathematics, SYBSc Hadapsar. This is our fifth lecture on limit and continuity. Now, in this lecture, we are studying the theorems. Only statement, not a proof. If limit of f of xy at point AB, limit of f of xy at point AB in the domain D is exist, then it is unique. This means that the limit of f of xy is exist, then this limit is unique. Okay, now next step. Let f of xy and g of xy are the functions of two variables, x and y in domain D is a subset of R square and CB any arbitrary real number, CB any arbitrary real number if limit as xy tends to AB, f of xy is equal to L, and limit as xy tends to AB, g of xy is equal to M, then limit as xy tends to AB, f of xy plus g of xy is equal to L plus N. That is limit distribute on addition. Okay. Also for minus we get L minus N. Now next, this is first formula. Next, second formula is limit as xy tends to AB, limit as xy tends to AB, f of xy into g of xy is equal to L into M. Third formula is limit as xy tends to AB, C into f of xy, then then constant is goes to outside of the limit, we take C into L, and fourth one is limit as xy tends to AB, f of xy upon g of xy is equal to L upon M, provided denominator is not equal to 0. Also, these results are studied in 11th and 12th standard in a function of one variable. Okay. These formulae are used to solving the example. Now next, bounded function. Let f be a function of two variables on on domain D is a subset of R square on the domain D is a subset of R square, then F is said to be bounded function if there exists m greater than 0 real number, there exists a real number m greater than 0 such that mod of f of xy is less than or equal to m for all xy belongs to D. It means that all image value of D is less equal m. Then it is called as म्हणजेच काय असतं बघा, let f be a function of two variable on a domain D is a subset of R square, then f is said to be bounded if there exists m greater than 0 such that mod of f of xy is less equal to m. means सगळ्या इमेजच्या ज्या व्हॅल्यू असतात f of xy च्या त्या m पेक्षा काय पाहिजे, लेस इक्वल पाहिजे, आणि सगळ्या व्हॅल्यू साठी जर हे होल्ड झालं तर आपण काय म्हणतो, दिस फंक्शन इज सेड टू बी बाउंडेड फंक्शन. नेक्स्ट Next is if limit of f of xy exists at a point AB, then समजा f of xy is at point AB ला जर लिमिट एक्झिस्ट होत असेल, then f is bounded in some neighborhood of deleted neighborhood is bounded in some deleted neighborhood of point A. म्हणजे AB हा पॉइंटला जर त्याचं लिमिट एक्झिस्ट होत असेल तर त्या पॉइंटच्या कोणत्या तरी एका म्हणजे सम नेबरहुड मध्ये हा पॉइंट हे फंक्शन काय असतं, बाउंडेड असतं. दिस फंक्शन इज बाउंडेड इन सम डिलीटेड नेबरहुड ऑफ पॉइंट A. नेक्स्ट करूया जर f of xy is bounded in some deleted neighborhood, I can tell neighborhood by NBD, deleted neighborhood of AB, and the condition is that f of xy are bounded असेल some deleted neighborhood of AB and limit as xy tends to AB, g of xy is equal to 0. म्हणजे f of xy पॉइंट A ला काय असेल, बाउंडेड असेल त्या नेबरहुड मध्ये, आणि g of xy लिमिट जर 0 असेल then limit as xy tends to AB, f of xy into g of xy is equal to. This result is most useful in the limit. So if f of xy is bounded in some deleted neighborhood of AB, f of xy हा bounded असेल आणि g of xy चं लिमिट जर 0 येत असेल तर f of xy into g of xy चं लिमिट काय येतं 0 येतं. f of xy into g of xy चं लिमिट काय येतं 0 येतं. ओके, next theorem is a sandwich theorem. Next theorem is a sandwich theorem. Let f of xy, h of xy and g of xy are the functions of two variables, and f of xy is less equal, h of xy is less equal g of xy for all xy belongs to D, for all xy belongs to D, for all xy belongs to D, or for any deleted delta neighborhood of AB and limit as xy tends to AB, f of xy is equal to 0, sorry, L. The f of xy limit to the L असेल and limit as xy tends to AB, g of xy is equal to L, then limit as xy tends to AB, h of xy is also L. It means that f of xy and g of xy are sandwiched to h of xy. It means let f of xy, h of xy and g of xy are the functions of two variables. F of xy is less equal, h of xy is less equal g of xy. That is h of xy is the middle of f of xy and g of xy for some delta neighborhood of AB. This one delta deleted for some deleted neighborhood of AB and limit as xy tends to AB, f of xy and limit as xy tends to AB, g of xy is equal to L. That is lower limit is also L and upper limit is also L. So we get limit as xy tends to AB, h of xy is also L. म्हणजे f of xy चं जर लिमिट L असेल आणि g of xy सुद्धा लिमिट L असेल तर h of xy सुद्धा लिमिट काय असणार आहे L असणार आहे. ओके, next evaluate limit as xy tends to 1 to 3x square y plus 5x square y square. So this function is continuous, so directly putting the value of x and y we get limit as xy tends to 1 to 3x square y plus limit is distributed xy tends to 1 to 5x square y square. Also constant is outside of the limit and we get limit as xy tends to 1 to xy tends to 1 to x square into limit as xy tends to 1 to y plus 5 into limit as xy tends to 1 to x square into limit as xy tends to 1 to y square is equal to 3 into 1 square is 1 into 2 plus 5 into 1 square is 1 into 2 square is 4 is equal to 3 into 2 6 plus 20 is equal to 26. Okay. This is basic example of limit. Now we see the example. Show that limit as xy tends to 0 0, limit as xy tends to 0 0, x square sin square y upon x square plus y square, x square. Now solution, here we take f of xy is equal to x square upon x square plus y square, and g of xy is equal to sine square of y. We know that x square is always equal x square plus y square. X square is always less equal x square plus y square. This implies x square upon x square plus y square is less equal 1. Taking mod on both sides, we get mod of x square upon x square plus y square is less equal 1. This implies mod of f of xy is less equal 1 in delta neighborhood of deleted delta neighborhood of delta neighborhood of point 0, because at 0 0 this is not defined, but in a neighborhood of delta neighborhood of 0 0 this function is bounded. Okay, now and you know that limit xy tends to 0 0, limit xy tends to 0 0, g of xy is equal to limit xy tends to 0 0 sine square. If we put in value of y, then sine 0 is 0. Therefore we get limit as xy tends to 0 0, g of xy is equal to 0. Therefore, by previous theorem, that is, if f of xy is bounded, and g of xy goes to 0, then f of xy into g of xy goes to 0 at point A. Okay. By this theorem, we have limit as xy tends to 0 0, limit as xy tends to 0 0, x square into sine square y upon x square plus y square is equal to 0. Now next example is using sandwich principle. Show that using sandwich principle, show that limit as xy tends to 0, 0, tan inverse of xy upon xy is equal to 1. Using sandwich theorem, show that tan inverse of xy upon xy is equal to 0. Solution: for any x belongs to R, for any x belongs to R, we have tan inverse of x is equal to tan inverse of x is equal to tan inverse of x is equal to 1 minus tan inverse of x is equal to x minus x cube upon 3 plus x raised to 5 upon 5 minus and up to so. This is Taylor's series expansion of tan inverse of x. Tan inverse of x is equal to x minus x cube upon 3 plus x raised to 5 upon 5. This implies tan inverse of x upon x is equal to 1 minus x square upon 3 plus x raised to 5 upon 5 and up to so. Okay. From this, we get 1 minus x square upon 3 is a less equal tan inverse of x upon x, which is less equal 1. म्हणजे इथं बघा त्याच्यामध्ये ऍड करतो इथनं पुढची टर्म, म्हणजे ही काय असणार आहे लेस दॅन दिस टर्म असणार आहे आणि 1 मधून ही मायनस प्लस त्याच्यापेक्षा ही लहान असते, बरोबर आहे. त्यामुळे ही मायनस प्लस होतं, त्यामुळे 1 हा काय असतो सगळ्यात मोठा असतो, त्यामुळे आपण काय घेतलं विच इज लेस इक्वल 1. ओके. बट ऑल्सो x into y is not equal to 0, that is xy is not equal to 0. This implies 1 minus, this result also true for xy, that is 1 minus xy square upon 3, which is less equal tan inverse of xy upon xy, which is less equal 1, which is less equal. Okay. Now here f of xy is equal to 1 minus xy square upon 3. H of xy is equal to tan inverse of xy upon xy. G of xy is equal to 1. Okay. म्हणजे f of xy हा घेतला, h of xy हा घेतला आणि g of xy हा घेतला. Now limit as xy tends to 0, 0, f of xy is equal limit as xy tends to 0, 0, 1 minus xy square upon 3. If we put the value of x and y is 0, 0, then we get the value is 1, and also limit as xy tends to 0, 0, 0, 0, g of xy is equal to limit as xy tends to 0, 0. The limit of constant is also constant, that is here we know that f of xy is a less equal h of xy is a less equal g of xy, and the limit of f of xy and g of xy is L, that is here is 1. Then by sandwich theorem, limit of tan inverse of xy upon xy, that is limit of xy tends to 0, 0, h of xy is equal to h of xy is equal to limit as xy tends to 0, 0. Here h of xy is a tan inverse of xy upon xy, is 1 by sandwich theorem. Okay. ह्या एक्झाम्पल मध्ये काय केलं बघा. पहिल्यांदा आपल्याला दिलेलं होतं की हे सोडवायचं आहे. लिमिट ॲज xy टेंड्स टू 0 0 tan इनवर्स ऑफ xy अपॉन xy 1 दाखवायचं आहे. त्यासाठी आपण tan इनवर्स ऑफ x चं एक्सपान्शन बाय टेलर सिरीज काय येतं x minus x cube upon 3 plus x raised to 5 upon 5 and up to so on. Okay. Then tan inverse of x upon x चं काय येणार आहे 1 minus x cube upon x square upon 3 plus x to 4 upon 5 x raised to 4 upon 5 and up to so on. Okay. जी व्हॅल्यू x साठी satisfy होते ते xy साठी सुद्धा होते म्हणून x is replaced by xy. Then we get tan inverse of xy upon xy is equal to 1 minus xy bracket square upon 3 plus xy raised to 4 upon 5 plus and up minus and up to so on. We see that the 1 minus x square upon 3 is a less equal tan inverse of xy upon xy and whole value is less equal 1, so we get 1 minus x square upon 3 is a less equal tan inverse of xy upon xy which is less equal 1. Here f of xy is the 1 minus x square upon 3, h of xy is the middle value and g of xy is the last value. Okay, therefore by using sandwich theorem, what is sandwich theorem? If f of xy is less equal, h of xy is less equal g of xy and the limit of f of xy and g of xy is L, then limit of h of xy is a L. So we are finding the limit of f of xy. For finding limit of f of xy, limit as xy tends to 0 0 1 minus xy square upon 3 1 minus xy square upon 3. If you put the value of x and y is 0, then we get answer is 1 and limit as xy tends to 0 0 g of xy that is 1 is also 1. So we get by sandwich theorem limit as xy tends to 0 0 h of xy is also 1, that is limit as xy tends to 0 0 tan inverse of xy upon xy is a 0. Okay, now we complete this point. Okay, now thank you for watching this video. Thank you very much.